Alright, so in this video we are going to talk about solving aquatic, there you go. We're going to solve quadratic, the aquarium classes, that's next class. Anyways, solve the quadratic equations using the quadratic formula. What does that actually mean? We're going to take this long, looks kind of big, looks kind of scary right now, but it's actually going to help us a lot. It's going to make things easier for us. But we're going to use the quadratic formula to solve a quadratic equation. ax squared plus bx plus c equals 0. This one's in standard form. We're going to use the a, b, and c values, the coefficients, by evaluating. So we're going to evaluate what? We're going to use this and take the coefficients and plug them in here. And this is going to give us two answers. It's going to give us the roots and it's going to give us the x-intercepts for a parabola. It's going to give us the roots. Here's the x-axis right here, vertex, the y-axis, and you've got the roots right on the x-axis there. All right, so let's see how we do this. Example 1. Solve x squared plus 9x plus 14 equals 0. The solution starts off with, we're going to identify the coefficients of the quadratic equation. A, this 1 comes from 1 that's right there in front of the x. You don't see it. Remember, that's implied. 9 comes from the b, which is right there, and c comes from the 14. So I have my a, b, and c that I'm going to plug into the quadratic formula. Next step. Substitute into the formula. Take the 9, plug it right here. Take the 9 again and plug it here. If you remember, this is b, b, this is going to be a, c, and a. So the 9 goes in for the b. Where are we at? The a for the 1 and 14 for the c. And then again, the 1 gets inserted for the a. That's the correct setup right there, using the coefficients of 1, 9, and 14. So next step is to simplify. The way we do that is we just start doing the math with the quadratic formula. First step, a negative times a positive gives us a negative 9. Plus or minus the square root of 9 squared, which is 81. And then a negative 4 times 1 times 14 will give us a negative 56. All of that divided by 2 times 1, which is 2. So far, this is what we have. We simplified it from here to here. And we're going to simplify this part on the next step. And you can see we get the square root of 25. Everything else is still the same. Negative 9, plus or minus, and the square root of 25 over 2. So far, so good. I rewrote it up here for you. So this is where we started, and we're going to simplify all the way. Remember, we're going to get two roots here. So negative 9, we all know the square root of 25 is 5. So negative 9 plus or minus 5 divided by 2. So I just took this, and here's where we're at. Is going to equal, now this is where we're going to split up into two solutions. Negative 9 plus 5 divided by 2. Negative 9 plus 5 divided by 2. And negative 9 minus 5 divided by 2. Negative 9 minus 5 divided by 2. Now I'm going to start working it out down for the two solutions here. This ends up being negative 4 over 2. That's negative 14 over 2. And x equals negative 2 from here and negative 7 from there. That means I have two solutions. I've got my parabola, I've got the roots, I got the x-intercepts, that's these guys right here. That would be like -2, -7, if that was the x-axis there for these two solutions. Okay, let's solve another one. 2x squared minus 3x equals 8. This is a little bit different. Before, it equaled 0. We have to have it in standard form before we can start, because that's going to tell us what the A, B, and C are, the three coefficients that we need. Write in standard form first, and then we're going to note the coefficients. So what we did was 2x squared minus 3x, and I have -x now equals 0. How did I get that? That came from, all I did was inverse operation on the +8 to get it on this side of the wall. So I've got -8 equals 0, which means now I know what A is, that's 2. I know what B is, that's -3. And I know what C is. C is -8. And the second step, substitute all the coefficients properly into the quadratic formula. That's going to be a negative, and the B goes in here, -3. From here, -3 goes right there. A -3 gets inserted again underneath the square root here, and we're going to square it. Minus 4 times AC. So 2 is A, C is -8. All of that divided by 2 times 2, which was 2A. So that's the correct setup for it. And now we're just going to simplify down to get the answer. Negative times a negative is a positive. Positive, or plus or minus, square root, and -3 squared. That's 9. A -4 times 2 is a -8, and negative times negative is positive, so we have a +64 here. Divided everything by 2 times 2, which is 4. Now you might be looking at this, and you might be looking at the 9 and the 64. You see the square root there, and you could be tempted to go, well, that's probably just 3 and 8, add them together, and I'm outside the square root sign. Don't do it. Not allowed to do that yet. You're just going to have to play this as if it was in parentheses. This is a grouping symbol, if you remember. 9 plus 64, you have to add them, and then we'll take care of things later. What does that look like? The next step, I'm coming back over here. That's going to be the +3 plus or minus the square root. 9 plus 64 is 73. All of that divided by 4. So please don't just, take that out right now. You're not allowed to do it. You have to do the addition. Remember, anything in parentheses, you got to do everything inside the parentheses before you're allowed to do other things. So leave that alone. Our next step is, this is where we're gonna split it up into 2. I'm going to take 3 plus the square root of 73 divided by 4. So 3 plus the square root of 73 divided by 4, and 3 minus the square root of 73 over 4. 3 minus the square root of 73 over 4. These answers right here, if I had a calculator, then I would punch them in there, and I'd find out what the square root of 73 is, and I would work it out. You would get 2.89. Over here, if you punched it out, you would get -1.39. Again, 2 roots. If you look here, you'll see that this is a positive in front of here, which means it opens up. And I would have 2.89 and -1.39. That would be like -1.39 here, 2.89 here. It opens up just like that. And that would be our parabola and our roots and our intercepts, and we would have the answer that quickly. You can see this, the benefit of the quadratic formula is to just quickly get your x-intercepts, and also have the answer. We could plug this in for x up here, and it will work out. So another example. This time you can see here, I put the y in front. We're going to find the roots, we're going to find the x-intercepts, and we're going to find the solutions of y equals x squared plus 4x minus 5. And I think this is a good opportunity for you to pause, see if you can figure that out first, see if you can get your two solutions, and then come back to the video and you can work it out with me. I'm going to work it out right now, but pause it and try it. See what you can do first. Alright, here's my thought process to work this out. I know for sure, I remember we said step one, write in standard form, and then that way we know what our coefficients are. Well, y equals x squared plus 4x minus 5. I'm just going to change the...
Yadira Nunez, please come to the office. Yadira Nunez, please come to the office.
I'm just going to change the y to 0. And we got x squared plus 4x minus 5. I just rewrote the equation. It's in standard form now because it's equal to 0. That means I know that a is 1 from here, b is 4, and c equals negative 5. Negative 5 from there. Step 2. Basically sub and solve or simplify. So let's substitute it into the formula. It starts off with the opposite of b, so let's insert b, plus or minus the square root of b squared, that was 4 squared, minus 4ac. 4 times, where's our a? That's a 1. And this time our c is negative 5. Let's make that a little bit longer. Whew! All of that over 2a. So 2 times, here we go, 2 times 1. Okay. Double checking, make sure I did everything right. Looks really good so far. Now we just, step 3, we just simplify. Whoops, let's make that a little better there. Simplify. Well, we can just start out here real easy. Negative 4 plus or minus the square root of, take that way over here, and 4 squared, 16, minus a negative 4 times 1, that's negative 4. And a negative 4 times a negative 5 ends up being a plus 20 right there. And all of that is going to be over 2. Alright. Now all I need to do is just add these things together. Kind of running out of room here. I'm going to squeeze it over here. Negative 4 plus or minus 16 and 20 make 36 over 2. And you might see the connection there. Square root of 36 is going to be 6. So if it's alright with you, I'm going to go ahead and start. I'm going to split it up right now. A negative 4 plus the square root of 36, which is 6, divided by 2, and negative 4. This time I'm going to subtract the 6 all over 2. So on this side I get a negative 4 and a negative 6 is negative 10 divided by 2. That's a negative 5. Negative 4 plus 6, that's a positive 2. Positive 2 divided by 2 equals 1. So my roots, x-intercept should be 1 and negative 5. We're just going to double check this one with a graph. I just want you to see what it looks like with a graph. But you could actually, if you wanted to, you could leave your answer like that for me on paper. That would be fine. Box your answers there, and I know that you would do it right. But I'm going to show you this one and double check it on a graph just so you can see what it looks like. Okay, remember, my roots or my solutions were x is 1 and x is -5. I got the x and the y here. I did by 2's, just trying to squeeze. It was kind of a big graph, so I went by 2's there. And if you just look here, x is -5, that would be right there on the number line. Plot that one. X is 1, and I'm going to plot that. Remember, the equation was x squared plus 4x minus 5. I actually went ahead and behind the scenes, you know, I did all the x's and y's, a table and all that. The vertex was right here at -9 for y and -2. So this was negative, the vertex. You can see here, -2 and -9. One of the points right here, the y-intercept, I do want you to note that. Look at this. Y-intercept is at -5. Look and see what has in common. We haven't talked about this yet, but look what has in common with this quadratic. The -5 happens to be the letter C. Remember, that's C, and that's B, and that's A. The y-intercept in a quadratic is the C number here. So anytime you read this, at least you're going to know somewhere if there's a C involved. If it's 0, then of course it's going to be right there. But it'll be 0. Yeah, it'll be 0 right there. If there's a -5 or a +5, it's going to be somewhere the graph will cut through there. Notice it just happened to cut like on, you know, this side of it. It didn't cut it. It didn't cut it at the vertex, so don't think that it always goes right at the vertex. It actually cut like right here. It might cut here or here, but just know that -5 is the y-intercept there for a quadratic, or C is the quadratic for the quadratic. The x equals 1. I just plot that, but you can see here these are the roots. The vertex, y-intercept. This was another point that I calculated out for you, and that's pretty much it. Using the quadratic formula to solve an equation. Find your ABC. So we can sum this up. Step 1. Write. Wow, that's a horrible W. Write in standard form ax squared plus bx plus c equals 0. Step 2, sub the values into quadratic formula. And 3, simplify to find, well, sorry about that. Simplify to find the solutions, which are also the roots, which are also the x-intercepts. They're all related. That is some of the worst writing I've ever done, and I apologize. But this should give you a big picture and a really good picture. I look forward to seeing you in class.